Good. Ooh, let's pause that for a moment. Good afternoon and welcome everyone this afternoon. Thank you very much indeed for being with us when the day is so glorious outside. Thank you for giving us your time. Afternoon session is a CPD session on how drones can transform heat loss monitoring and measurement. And we are running this whole series in conjunction with Connected Places Catapult. As I've mentioned, a couple of housekeeping points. Please stay muted and your cameras off. Do ask questions via the Q&A function at the bottom of the screen, and I will add email details for you to be able to contact us afterwards. Today's session is kindly being led by Steve Welland, who is the training manager at iRed. It will focus on best practice and the use of thermal imagery to help the move to net zero. Thermal drones save lives, increase safety, boost efficiency, and gather crucial real-time insights and maximise return on investment. When it comes to utility or building inspections, a drone equipped with a thermal camera can be a game changer. Thermal cameras enable you to see missing or damaged insulation, water under roof membranes, external electrical issues, failed windows, and many other problems. They also allow operators to reach tough to access spots quickly, easily, safely, whilst reducing traditional investigation costs. Steve is an ex-forces instructor, accredited PCN Category 2 thermographer. He is a CAA approved drone operator and certified training instructor with over 25 years in the training industry. Alongside his training responsibilities, Steve is also the in-house payload specialist for iRed, providing multispectral and thermal camera integration for aerial inspection services. And the other thing I would also add is that he's absolutely passionate about his topic. He will talk very well, very succinctly and passionately about what the topic is today. So Steve, I'm going to hand over to you now. I'm going to put myself onto mute and turn my own camera off and enjoy listening to you. Thank you.
Good afternoon, ladies and gents. As you've heard from Eleanor, my name's Steve. I'm the training manager at iRed, and I'm here really to talk to you this afternoon about infrared cameras, primarily from an aerial perspective, which is mainly, hopefully, what we're interested in, and mainly to do with the built environment, because of the current topics that we all are aware of in getting to carbon neutrality, etc., in the coming future. So I'll start by looking at some of the drivers for this, and just bear with me. Okay, so some of the buzzwords and the statements that we hear bandied around at the moment and are not becoming really important. Things like cutting carbon emissions, zero emissions, climate change, net zero. Okay, things between 2020, 2050, the UK is committed to reduce greenhouse gas emissions to net zero. All these statements are important to drivers into understanding the domestic and commercial buildings state in the country. And of course, the technology we have available is a great tool to understand and get to grips with what might be required to do with these properties. It says housing accounts for about 14% of the UK's greenhouse gas emissions due to poor insulation, gas heating systems, okay, and in England between only 2 and 9% of these measures have actually been started to be installed. So when it comes to retrofitting and upgrading, the way forward is to use thermal imaging, and a tool like a drone, for example, will quickly identify issues, providing clear images and information and recommendations for focusing on actual problems and therefore saving time and money. Okay, so those drivers in place, what we need to understand is what is the technology all about? There's a lot of misunderstanding with infrared. Quite often people think that infrared is a tool that you can open the box, get the camera out of the box, point and click in the given direction, and it will show you everything that you're there to find. This isn't anything like that. The it's no different really to photography in a way that if you're untrained photographer, it's very difficult to get a great image. And with infrared, there's a finite amount of thermal radiation that we're trying to see and understand, and many objects in our way and obstacles in our way to stop us from achieving what we need to achieve. So the thermal image is effectively trying to turn what is invisible to the naked eye into a visible image. The radiation that emits from a surface is detected by the camera. The camera will then have those as number values, and then we, and I stress the word we, as thermographers or people that are using thermal cameras, can apply colours to those values. Okay, and there's a choice to be made how you apply those colours. If you just point the camera in the general direction of the target and press click and then interpret that image straight out of the camera, there will be a choice made by the camera's internal software as to which the hottest pixel is in the image and the coldest pixel is in the image. And that will unfortunately span the image incorrectly most of the time, not showing you what it is you're actually looking for. So cameras are not particularly clever, and when you capture the image, there is a raw amount of data captured. One of the other things that's misunderstood is the camera's resolution. We only have, in the best possible case, when it comes to drone thermography, 640 pixels along the long edge by 512 pixels along the short edge. That equates to around about 327,000 pixels. In the average mobile phone, we've got 12 million pixels. So there is a massive difference in resolution. And each one of those pixels is effectively a temperature. And we apply colors to that temperature. So the image you can see on the screen at the moment, you can see that this particular palette has been applied to those 327,000 cells of temperature, and it gives us the image that you can see in front of you. We would then tune that image to draw out and color the way we want to color it, the information we're looking for. So in this particular image, it was tuned to see that heat loss that we can see on the end of the elevation. That might not necessarily be this clear if you just clicked the camera. Here's another example of taking an image and tuning the image correctly to see what we need to see. And I can assure you the image that came straight out of camera would not be anything like this. This takes a good selection of tuning and the right choice of palette as well. As interest goes in the built environment, we tend to use rainbow high contrast for a very important reason. You'll see lots of images all over the place in various other palettes. Ironbow seems to be a favorite because it makes things look nice. But we use rainbow high contrast for a very specific reason. The idea is to see gradient changes in color. You need to be able to identify, because it's a qualitative evaluation, a change in temperature, and easily. If we use other palettes like Ironbow for this type of work, then what we have is a very smooth blended image, and we can't really tell where those definitive changes are. If we look at this image, we can see exactly where the problems are with the insulation. As we said, aren't they just point and shoot? Well, no, they're not point and shoot, as I've just discussed. And this particular image you can see here was required, because of the size of the building, to be collected as a composite image. So this is an image with probably somewhere in the region of 40 images, stitched together in a traditional panoramic way, but now it becomes a high resolution image, and we can also see the heat loss in context, which becomes a really important way of confirming with your customer what the problems are. Nothing worse than looking at 40 individual images looking at a very small portion of the scene. And we can't afford to go back away from the scene to fill the frame with our elevation, because all we're doing is moving away from the target surface. And if we move away from the target surface, we lose radiation. Radiation that's emitting from surface is absorbed by our atmosphere. So we want to be as close to the target as we possibly can. And a way of getting as close to the target as we possibly can is to make multiple images of the scene. Okay. So applying color to the images is the thermographer's most important choice. If you look at this building here, they're both exactly the same building, but which one of them is losing more heat? And traditionally, most people would look at the image on the left with the red and say that's losing heat. And of course, they would be right, but that's not necessarily the whole story. It's my choice as a thermographer how I apply color to heat. And I can make whatever I like look red. Red doesn't necessarily mean it's the hottest in the scene. So if we now look at the next image, when we add a scale, now we have a scale, I can see that the image is exactly the same. But all that's happened is we've moved the scale up 3 degrees, which has now made the elevation look cold. So again, this is something that you have to learn about infrared. When you put your images together, it's your choice to scale the image correctly. And there's all sorts of reasons why we make sure we have the same scales for outside, and we have the same scales for inside, so we can detect different temperatures. We shouldn't be allowing the camera to auto select a scale, because every image you take will have a different scale based on the hottest pixel and the coldest pixel in the scene. So I think this again highlights the point that when we capture an image, the image has to come out of the camera and go into a good piece of software for you to do the work that's required after you've captured your image. We would call that stage thermal tuning, and it means to control the image with range, level, and span. Excuse me. So using a drone in this situation can lead to all manner of problems. And of course, we use a drone because it's a great tool of getting an aerial perspective, as you can see here. But we've got to be careful on how far away from target we move. We've got to try to have the same fundamental understanding that we need to be as close to target as physically possible. Now, the only way of getting closer to a target to make sure you can see radiation that's emitting from the surface and not have that radiation absorbed by the atmosphere is to use the tools like composite your image together and make sure you've got the right lens. Okay, so a narrow lens is a far better choice for a drone camera than a wide lens. A wide lens gives you a great field of view, but unfortunately the subtle radiation leaving a target surface is going to get lost. It will see the big stuff, but it's not going to see the small stuff. And when we talk about heat loss, moisture ingress, when we talk about looking for continuity of insulation, those are all subtle changes in temperature. If we look at the rooftop directly in the middle of this image, there's some subtle changes on the rooftop in a lighter green. Those subtle changes would not appear if this was just a single shot from 30 meters away. That radiation will have been lost to the surrounding atmosphere. Okay, so when we talk about cameras and drones, then we have to have a look at our equipment. And this image that you can see in front of you now highlighting the Mavic 2 Enterprise Advanced, which is a great advancement on what's been available to us in the past. It's a 640 by 512 high resolution thermal imager in a very small package, and that in itself will allow us to utilize this drone in areas that might be difficult with the larger equipment. So we've now got a high resolution camera in a small package, which we've never had before. It's been very difficult to have that. And as I say, the minimum recommended resolution for any aerial camera, because of distance away from target, is the maximum resolution, which is 640 by 512. And again, if I repeat, if we put that into perspective, that is actually only 0.3 of a megapixel. So resolution is limited straight off the bat when it comes to infrared anyway. So some of the smaller resolution cameras are not going to work for the sorts of application I'm talking about today. When I say continuity of insulation, heat loss, moisture ingress, they're not going to be able to pick up that. The image you can see in this on this slide, anywhere where you see red or yellow, even from this 20-meter height, is moisture ingress on a roof that is in need of repair. So again, if the survey is done properly at the right time, in the right conditions, with the right camera, then there's no argument as to what the heat is that we've found. In this particular case, it's moisture ingress. Camera sensitivity is also very important and varies quite a lot, where the minimum recommended sensitivity is what we call for 50 millikelvin, okay, which is 0.05 of a degree Celsius. That's important to understand. So that measurement, 50 millikelvin, is not a fixed number for every altitude or every distance away from target. That'll be from 1 meter away from target in a calibrated environment at 30 degrees. So if we have any other conditions other than those stated, the 0.05 of a degree Celsius will change. It will be less than that. So the further we go away from target, the minimum sensitivity of the camera will change, and it will get less. So by the time we're 30 meters away from target, we're not going to be able to see changes of 0.05 of a degree. We might be able to see 1 or 2 degree changes, maybe less. All cameras really are required to be what we call radiometric cameras. Okay, and what a radiometric camera is, in its most simplest form, is a camera that captures that radiation leaving the surface as a CSV file or Excel spreadsheet or a grid of numbers. Okay, once we have that grid of values, then all other changes can be applied in software afterwards. So we call that a radiometric camera. The radiometric part, as I say, means it's collecting temperatures, it's recording temperatures. If you choose a camera that is non-radiometric, you have no temperature data, and therefore the image cannot be changed, and it will be considered a camera that can look at captured data in full in color, but with no temperature data. And as I said before, the idea is to have a good telephoto lens, something that is as narrow, it gives us as narrow as we possibly can go without compromising too much on field of view. And we settle on a 25 degree lens. Okay, the 25 degree lens is ideal. It seems that manufacturers want to give us the best of both worlds. A lot of the camera drones that are out there are not for or designed purposely for inspection work. They're designed for the search and rescue industry, which now in the search and rescue, this becomes less important. I wouldn't say unimportant, but less important to have a narrow lens, probably a bit more important to have a wider field of view. The problem with having a wider field of view is it effectively halves the distance we should be or can be away from target. So if you've got a 40 degree lens, for example, in the search and rescue world at 50 meters, you'll see twice the field of view than you would if you had 25 degree. Now, if you're in the inspection world, we lose half the radiation. So this image you can see here, we would then lose important radiation that could be moisture ingress by choosing a wider lens. Okay, this camera, new to the world, and then this week DJI bring out the M30, and we're into another camera which is based on this. So Why is this the new kid on the block, and why is it so different? Well, we have that high resolution again, but more importantly, we have some improvements on sensitivity. This camera is a 30 millikelvin camera, and one of the downsides to infrared, as you probably picked up in some of the images we've seen already, is they can be quite noisy if we're looking at small temperature differences. When I use the term noisy, I mean there's speckles of noise in the image, which makes them look less clear. And of course, that means the image is going to be less sensitive. So when we have a camera that has improved sensitivity and down to 0.03 millikelvin, well, effectively, this means that we can now fly higher and see the same amount of radiation. Okay, so we're now utilizing the drone's ability to fly higher. Again, we can fly higher, we can get a bigger field of view. So all these improvements that we see coming onto the market make our life easier, and as long as we understand all of that, we can therefore choose the right height and not be missing any radiation. The camera's great. I've yet to get my hands on the M30 edition of this. Having looked at some of the videos, I do think there is a difference, and I'm sure there will be a consequence of crushing this camera into a smaller space. When we crush a camera into a smaller space, we end up increasing the signal to noise ratio and therefore having a bit of a problem with sensitivity. So we might find that the M30 H20T is smaller, and therefore we'll end up with a little bit more noise and less sensitivity. We'll have to wait and see. There's some examples of drones that carry that. These thermal cameras, they're all fantastic drones, very easy to fly, very easy to capture great data. Now we've got some great cameras to fit on those drones as well. Okay, so the last thing we've got to talk about once we've talked about cameras, drones, is they're useless pretty much without software. And everybody's going to have their favorite piece of software, and everybody have their favorite manufacturer. Those are very subjective details. We've landed as a company on Flir software because it seems to be the most comprehensive and well used and understood piece of software. Currently, Flir Studio is their main piece of software. There are some more expensive pieces of software. There's a piece of software called Research IR Max, and there's some older software that we call Thermocam. They're all great pieces of software. The one thing to take away from this is you cannot really, if you're going to enter into the world of infrared and heat loss in the built environment, you absolutely must understand a piece of software and how it works when it comes to analysis and thermally tuning your image. Flir Studio is, like I say, a great new piece of software. Allows you to tune your image, allows you to make sure you pull out the detail in the image, and then present that image to your client through the form of report writing. So this is a great piece of software. Now, the downside to buying a DJI piece of software with a thermal camera on it at the moment is their thermal tuning piece of software that they write for the H20T and the Mavic Advanced is not really up to the standards of general infrared understanding. It has a very basic function. It will allow you to change the palette. It will allow you to change the scale slightly. It doesn't work in the way that it should do. Without raining on DJI's parade too much, the software I don't think is fit for purpose for infrared tuning. So those cameras, the H20T and the Mavic Advanced, unfortunately don't allow the image to be taken from the camera and put into a Flir piece of software. Previous iterations of DJI drones, XT2, the XT, they do work in Flir software. DJI took the decision to make it proprietary, so they have to be converted. And there's a great piece of software out there called the Thermal Converter, which allow you to take an image out of an H20T and out of a Mavic Advanced camera and tune it as if it was a Flir radiometric JPEG, which is a great addition, which is why the cameras are able to be used. Okay. So here's some examples of imagery that's been taken with this equipment. And the point we're going to make here is we have to make sure that not only have we got the right camera, the right drone and the right software, but we now have to make sure that we're taking the imagery in the right conditions and at the right distance based on the environmental conditions. Now, this particular building is a building that was taken on a low humidity, clear night. Okay, and I emphasize the word night. Nothing really can be done during the day to any quality. I'm not going to suggest that infrared heat loss can't be done during the day, because I'm sure there are plenty of people out there that would argue with me. I would always disagree. The BREEAM spec requires you to do it when there is no solar gain, and therefore these things have to be done when the sun has gone down and the solar radiation that has affected the surface of the building has dissipated. So we always talk about doing heat loss surveys after dark, a couple of hours after sunset, when the solar gain has dissipated from the building. And these are perfect conditions, and this is probably as good as it gets. In terms of a thermal image, this is sharp. All the detail is there. We can even see the brickwork and the mortar in the brickwork. So when it comes to radiation emitting from a surface and being able to detect everything that's available, this gets no better. The conditions were, like I said, clear night, cold, and low humidity. When we look at the next image, the next image is taken of the same building, but on the following night. And on the following night, the only conditional change was that we had a humidity level of 85, maybe possibly even a bit higher, and full cloud cover. And just that one condition has meant that the survey is now no longer possible. The image is not only lacking in radiation arriving at the lens or at the camera, okay, because it's being absorbed by all of the H2O in the atmosphere. Okay, so this, as we can see here, compared to the previous image, has no real information that we can glean from the image. It's a very important point. So deciding when you do the survey is super important. And unfortunately, the nature of infrared radiation leaving a target surface and being absorbed by O2, CO2, and the worst one, H2O, okay, will determine, your choice will determine whether you can actually do the job properly or not. I think that's a telltale sign of how important it is to understand infrared and what's required when it comes to survey preparation. So survey prep, what we need is we need to heat the building. The building, regardless of what building it is, it needs to have the fabric of the building, the construction of the building needs to be heated fully, not the air temperature inside. If we have a building that has only had its heating system switched on for an hour and all it's managed to heat up is the air inside, we end up not being able to identify these changes in temperature from inside to out, and therefore not be able to identify things like continuity of insulation or missing insulation, etc. We need to make sure that the surfaces are dry, and that includes dampness, because a surface that is in a condensative state has a warming effect. If it's in an evaporative state, it has a cooling effect. So those two states we don't want to enter into. So we want dry surfaces. We want no obstructions. We want as little obstructions as we possibly can. Now that one on its own is quite difficult when you're talking about doing an occupied homeowner who's got furniture, etc. That we have to deal with. But as far as possible, we want to have as least obstructions as we possibly can. And we want no solar radiation. This image here is a great example of how the sun has affected the surfaces of the building. The blue area on the building is because that's the shadow from the building behind it. The white areas, the red areas, and all the way down the street on every other house is just where the surface has been warmed to the extreme by the sun. So this survey will have to wait another couple of hours for that to dissipate. Once it's dissipated and it all starts to even off, then we can go ahead with our survey and look at the continuity of insulation, for example. The other thing is we quite often disregard the wind. The survey prep, we need to talk about having less than 5 meters per second wind blowing across a surface. That's 10 miles an hour, roughly. So it's not really the drone that's the controlling factor when it comes to when we carry out the service in wind. It's because a 10 mile an hour or more wind blowing over a surface will artificially cool that surface. If you combine that with wet or damp surfaces and solar radiation, effectively now with all those three things taking place, there is nothing of the heat loss from the heat coming out, leaving the building that we can see. It's all, evaporative state, it's all solar radiation, or it's all wind cooling the surface. So it can be quite awkward to plan and do these types of surveys. The one thing is clear, that the best time of year to do this is between September and April. And we are already at the point in our workflow where we're having to organise heat loss surveys for later in the year, because we've got beautiful late daylight today, where this evening it could take until 9 o'clock for the solar gain to dissipate from a building surface. And that might not be a great time for the client to want to have people crawling all over their properties. So this is can be a winter job only. Okay. So what can be achieved once you put all that together? We end up with some great images like you can see in front here. And now these are the overview images. There will also, for each one of these properties, there will be lots of these style of images, but this gives you an example of what we can see going on and how we can utilize these images. Now, because they're contextual images and they're high resolution, because they're multiple images, we can zoom into certain areas and we can zoom back out again and still see that radiation in context, which is why we do it this way. If we were to do this with a drone over these buildings with single images, you could have a 70-page report and be looking at little tiny sections of the rooftop, which is really almost impossible to understand. I must stress here, though, that this is not photogrammetry, which is a complete another topic which might talk about another time. Here's another example of an entire rooftop, and we can see the entire area with all of the radiation available, with lots of context. And we can even see on this one, which is a roof survey, we can even see that the area, the solar gain is still not dissipated on some of the elevations of this building. But because we're looking at the roof, that's not something we're concerned with. Anywhere you see red in this image will be because of the sun. Here's where it gets a bit difficult. When we point a thermal camera at something that defies the physics, a lot of people don't realise the differences between glass and metal and how they reflect and how they don't reflect, how they absorb radiation, how they don't absorb radiation. Those topics are really important to understand, because when you get a building like this, in front of you, it can blow your mind a little bit. We've got a copper clad building here, and you can see that the copper is almost 100% reflector. The copper we will not be able to detect heat or any form of heat on those surfaces, because they are pretty much 98% reflecting the surroundings. And the glass is reflective to a certain degree, but nowhere near as the metal. So all of these factors have to be understood for you to come to a reasonable conclusion as to what's going on. And if you understand all of those factors, you can actually see through the problems that this is illustrating, because you understand where it's coming from. The black in this image here is effectively the copper reflecting the cold sky, which can be temperatures down to -20 on a clear night from those sorts of angles. That could be returning a value of -20, which is why it looks black. Okay, so we have some other techniques that we can use to gather information. It's great having the drone. That gives us an aerial perspective, but unfortunately, only 25% of what we do is the rooftop. So most clients want to understand external elevations and internal. So we have to either go and buy 2 cameras, which is very expensive, or get creative. Now, I've had some great students that have come through our doors and gone out the other side and had some great ideas of how to utilize the Mavic 2 Enterprise Advanced on a tripod, internally or externally, as a ground-based camera. And they've come up with some great imagery from this setup, which has saved them a fortune in the long run, or at least initially. Now, I wouldn't underestimate the fact that they're going to grow out of that scenario quite quickly, and they may well in the future want to buy themselves a ground-based camera, but at least it achieves, you can get some really good imagery, only paying for the price of a Mavic Advanced. If I was to say to you that the cost of having a Mavic Advanced for your aerial and a ground-based camera to achieve the same results as the Mavic Advanced, you're going to have to spend about 12k from a Flir manufacturer to get a ground-based camera that achieves similar results to the Mavic Advanced. So getting creative with a Mavic Advanced, using it for ground-based and aerial, and I've even seen guys utilize a 5-meter pole where the rules for flying dictate they can or can't fly. As soon as they get the opportunity they can't fly, then they put the Mavic Advanced on the top of a 5-meter pole. They're still getting their 2-3 story home rooftop inspected. They don't have to drive away, which means you know, that's a great way of doing it. Okay, and finally, we must understand that the client requires a deliverable. The client doesn't want a fistful of images, and the images you've seen are part of a comprehensive written report, which gives them the images in clarity and in context, and then notes and recommendations as to what might require doing to the building that's having the heat loss. Okay, I think what we'll do there is we'll pass it over for questions, Eleanor, and hopefully everybody's happy with what they heard.
Absolutely. Thank you very much indeed, Steve. So we have a question, so please do ask questions, obviously. We have a question in the Q&A section saying, is Parrot and Affy thermal suitable? Appreciate it is at entry level.
So this is a really good point, because the Parrot and Affy has a great, well, it's a Flir, effectively a Flir sensor. So we end up with this situation again where we can take the image out of the camera, put it into a Flir piece of software and tune the image. Now, the only thing I would say is that the working distance for a camera, when we talk about heat loss and looking for continuity of insulation, that's the bit that's not going to work. The working distance for a Parrot and Affy is around about 1 to 3 meters away from target. when you're looking for a missing insulation or moisture ingress, etc., etc. You may well be able to push those distances a bit more on a clear, concise night. In good conditions, you might be able to push that to say 5 meters away, 6 meters away from target. But I would say it suggests that at that point, at 5 meters away from target, you're now no longer seeing the radiation that's available. There's a great video on YouTube by a guy called Randall Warness from Flir that demonstrates the difference between a high resolution image and a low resolution image at distance away from target. So that might be something worth checking out. Sorry, Eleanor, I can't hear you.
I'm on mute, yep, apologies. Thanks, Steve. Excellent presentation. Thermal does seem a complex subject. How do I get to become a thermographer?
Okay, so there's a couple of ways to become a thermographer, and I do sometimes recommend the staged approach. Anybody that's going to do this for a business might want to skip the staged approach and just go straight in for a Cat 1, because that you're required as a comprehensive data collector to be qualified. Anybody that's not qualified is going to have a difficult time formulating a report and putting it in front of a client without those questions being asked. So a Cat 1 drone or course or Cat 1 general thermography course is the way to go if you're going to want to enter into the world of business. Now, if it's something where you want to go through step at a time, then we have an introduction to thermography course, which is e-learning. I think it's about £100. You just can go through that online in your own time, and that'll give you a good introduction to all of this. Then you can go on to have a 3-day or equivalent online understanding, where you're not going to be a qualified thermographer at the end of that, but you will most certainly know how to use a thermal camera both on a drone and as a ground-based product. And then if you want to be qualified, then we can do that additional couple of days to give you your Cat 1 qualification. So that's the best way to go about that.
Okay, there we go. Thank you. That's very helpful. Do airborne thermal and heat sensors play a role in police and forensics, or even missing person searches? Can this only be done at night, or do sensors daytime?
No, right. So we're into a different world now when we talk about search and rescue, and we train the police every month, and we've had a great relationship with a lot of the constabularies around the country. And one of the main points that as a thermographer I would say to them is, of course, their chances of finding a human in a search and rescue environment are going to be made more difficult by the conditions. And the retort to that is, it's better than nothing. If they don't have that drone up in the air, then they don't have anything to find them with. So although conditions make it quite difficult for these things to work properly, it's better than nothing. And some of these drones now are such high quality that that better than nothing scenario, of course, is improving all the time. When we can be deliberate in terms of search, when we can get to the right altitudes, understand the right conditions, and work properly with the given equipment, we're going to be able to find and utilize this in a search and rescue environment all day long. It's great equipment. If we're a little bit less deliberate and a little bit more rushed and more worried about the life and death scenario, then sometimes that we can miss stuff because the camera's flown a little bit too high, or the conditions might be bad. If it's raining, for example, you've only got to get a drop of water on the lens, and then that's like putting the lens cap on, okay, because water blocks radiation 100%. So there's some difficulties involved, but as I'm always told, it's better to have the equipment than not in a search and rescue environment.
Then we have, do airborne thermal and heat sensors play a role in, sorry, that one we just had, rereading things. Is thermal imaging ineffective in hot climates?
No, because we're not just talking about hot. That's a really good point, and it's one of the most common misconceptions. We're not only looking for heat per se, we're also looking for differences caused by emissivic changes in surface. Now, we're getting into a spiral down a rabbit hole very quickly if we start going into the science, but effectively thermal cameras are looking for differences. So even in hot climates, our temperature as a human being, for example, doesn't climb much above surface temperature 35 degrees. But if we're in, at the Saudi desert in 45-degree temperatures, there is still a significant difference between us and the surrounding ground. So hot climates, again, a great equipment. You just got to know how to use it.
Okay, we've had a couple of questions about how to find drone operators and if there is a registered of approved suppliers. I've added a brief note to say that ARPAS does have a list of a number of CAA registered drone operators. There are obviously plenty more.
Yeah.
There is a find an operator facility on our website. Obviously with that, it's with finding a drone operator, it's very important to make sure that they can provide you what you want. So make sure you've got your list of questions to ask them ready.
Yeah.
Another question on how does one become a registered drone pilot? Are there accredited training courses? Again, I've said that you need to train with a CAA approved training provider, otherwise an RAE.
Yep.
It has a number of these, and again, they're listed on our website.
Yep.
Beyond that, obviously, you will need to register and do various things for the CAA too. I will add some links as well for those too. But obviously, once you've done your basic training, there are a whole variety of other things that you would need to do, including, given that you're here today, thermal imaging.
Yep. Definitely.
How are we doing with questions? I think, has anyone got any more questions for us? If not, I think we may be done. I will just find the links. Appropriate. Very useful link through to the CAA website on everything about a whole variety of things to do with drones and remotely piloted aircraft, which is what the CAA are starting to call them. There's been in the past a big debate, and that is currently what the CAA approves of at the moment, most of all. Yeah. There we are. Oh, so here we go. Here's another one. In a different area. Is Cat 1 recognised in the EU? If not, do you know of other qualifications in the EU that may suit?
Okay, so the Cat 1, PCN Cat 1, okay, we've been British Institute of Non-Destructive Testing, it's internationally recognised. It's the only qualification that's internationally recognised. So as a training company, we're providing training for people within the EU and the Middle East, all over the world at the moment. So that is the only qualification that's internationally recognised. The other manufacturers' qualifications are carried out all over the world. ICT, for example, IC is carried out all over the world, but it's a Flir specific training course. And I don't understand whether it is or isn't internationally recognised like PCN is. So yes, our PCN Cat 1 is recognised worldwide.
So the questions seem to have been, we haven't had any more through. So I think we might finish there early. a few minutes early. Everyone gets a little bit earlier to go home and do their own thing now.
Okay.
Very much indeed, everyone, for attending, and thank you, Steve, for a highly interesting talk this afternoon.
No problem.
Of course, all the CPD sessions will be posted to the ARPAS website. We will contact you or let you know when they're available, so that if you want to, you can absolutely come re-watch them to your heart's content and make sure you get the absolute most out of all of them in terms of detail. Thank you very much, everyone. Thank you, Steve.
Okay.
And have a wonderful weekend.
And you.